Good morning. This remote meeting of the Climate and Energy Finance and Policy Committee is called to order, and the clerk will take the roll.
Chair Long.
Present.
Vice Chair Acom.
Present.
Minority Lead Swazinski.
Here.
Representative Bierman.
Present.
Representative Bowe.
Present.
Representative Christensen.
Present.
Representative Franson.
Present.
Representative Greenhagen.
Present.
Representative Hollins. Representative Hollins. Representative Hornstein. Representative Hornstein.
He's excused at Ways and Means.
Thank you very much. Representative Igo.
Igo present.
Representative Lee.
Lee present.
Representative Lippertz.
Lippert present.
Representative Lislegard.
Present.
Representative Meckland.
Present.
Representative Munson.
Present.
Representative Stevenson.
Present.
Looks like we have a quorum, members. Thanks so much for gathering this morning. We have one informational bill hearing today, and then we are also fortunate to hear from Dr. Tracy Twine on climate projections for Minnesota, and on the Working Group 3's report on mitigation. We had a number of questions on the second working group report, so I'm glad we'll be able to focus on the third working group. But first, today we will be having an informational hearing on House File 4436, and Representative Bolden is here to present that bill. Representative Bolden, would you like to describe the bill for us this morning?
I would. Thank you so much, Mr. Chair. And thank you to the committee for hearing this bill today. I am here today to present a bill from the city of Rochester related to a needed and renewable project that is really exciting. This is for a district energy system and key to our city's sustainable energy future. The district energy system would connect 5 public buildings near our city's downtown for efficient heating and cooling, and also would be able to connect into nearby properties as they're being developed. There are really exciting equity and environmental components to this project, and it is shovel ready. So before I turn it over to Councilmember Keene and Allison Zelms, the city administrator, to tell you a bit more about the project, I want to be sure that members of the committee are aware of the one-pager that was included in your materials. This document outlines the project and has some graphics that explain the 5 public buildings, which include the Rochester Public Library, the Mayo Civic Center, Civic Theater Building, Rochester Art Center, and City Hall that would all be part of the project. And with that, I will turn it over to Councilmember Keene.
Thank you, Representative Bolden.
Councilmember Keene, welcome to the committee.
Thank you. And thank you to Representative Bolden for helping to carry this bill along with Representative Liebling. And thank you to Chair Long and Chair Lee for working for your work on focus on energy projects in your committee. Good morning. My name is Patrick Keene, and I'm a city council member here in the city of Rochester. I also serve on our Rochester Public Utility Board. Our city council is very excited about this project, and we have ranked it among our top legislative priorities for the city. We are bringing this foundational and transformational project forward this year with an urgent need, because we have been informed that our current steam lines that provide heating and cooling for the city buildings is at the end of its useful life, and it will be turned off in 2023. If you visit Rochester, you will see steam escaping from manhole covers around City Hall and around our library, as a demonstration of how close we are to end of life. Without state support for this system, we would likely need to look at a system that relies on 1970s energy technology. We need state assistance on this project in order to make it a renewable and energy efficient opportunity for the future. Capital investments in 2022 and 23 for building management have implications for our city and state going out 40 and 50 years. At its core, our district energy plan is a much more efficient way to heat and cool buildings. It will be using geothermal upfront, and we will be setting the stage for other renewables to be added into the system over time. Again, this is a 50-year investment. As you can tell from the project one-pager that's in front of you and the other updates, this project is certainly shovel ready. And we are in an active design stages due to the urgent timelines we are working under. With that, I thank you for your time, and I'd like to introduce City Administrator Allison Zelms.
Thank you so much, Councilmember Keen. Ms. Elms, welcome to the committee. Please introduce yourself and proceed.
Thank you, Mr. Chair, committee members. Thank you, Representative Bolden, for helping us out with this. For the record, my name is Allison Zelm, City Administrator for the City of Rochester. We want to thank you again for the opportunity to talk with you today a bit about our project. We're really excited about it. As you probably wouldn't be surprised, we work frequently in supporting development of vacant land and redevelopment of other sites that are ready for reuse here in Rochester. And we do that always trying to focus on a triple bottom line. So we're keeping economic, environment, and social equity in mind when we're doing that. And this project is a great example of it. So on the environmental and sustainability front, the project is scalable and adaptable. It's going to implement advanced renewable energy technologies, which could include solar thermal, solar PV on our library or civic center. You can actually see our civic center here, our civic center and library here and City Hall here. So thanks for the ability to do this online. Our public and private development really will also further improving system efficiency as we continue to connect to the system in the future. It's a pathway to net zero buildings with future focus to allow for electrification, decarbonization, and clean energy. It builds on best practices and proven technology. And I believe the committee's heard about great opportunities for applying geothermal to new types of buildings beyond higher education, like Carleton College, which has been well underway in the state. So the project would be able to provide needed resiliency with multiple energy sources and equipment redundancies, which we can't forget about. Currently, we do not have any backup heating and cooling for City Hall, where many of our departments, including parts of our police and fire department, locate. On the social equity front, there is future private development of vacant land and parcels nearby that can connect to the initial build out of the system, and worth considering the possibility of affordable and workforce housing on those sites. I think we can all appreciate that lower energy costs from the system are key to affordable living. So that's very important. And then there's also a really exciting opportunity with this project for green job training with renewable technologies, training people through low barrier educational opportunities and how to manage these systems is really a marketable skill that aligns with the city's larger commitment and work with BIPOC populations in equity and economic development. On the economic and financial front, we expect decreased operational costs for the public building operations, with other systems seeing 25 to 45% savings from going from steam to hot water like we're proposing. In addition, we have adjacent vacant parcels for affordable housing. There's an amazing opportunity nearby with a 60-acre site, a former dairy processing plant and Kmart site that's in active plans for private redevelopment. And finally, there's a great opportunity for redevelopment all along Rochester's riverfront near the system as well. For those who may have been to Mayo Civic Center, the area nearby that building and across the river from City Hall is currently actively being looked at for redevelopment, and the district energy system could be a key part of that discussion. We've actually had a few private conversations where people have asked us about connecting in. In closing, I wanted to share our deep commitment toward this project, not only being something valuable to the city, but a catalyst and demonstration project. I've worked in multiple cities in Minnesota and around the country, and I can say with certainty that there's a really great information sharing that happens between local governments once someone has tried it out. And we're willing to share that learning. We're very committed to not only sharing that learning in Minnesota, the research and data and on-the-ground knowledge about our project with other interested key stakeholders is also going to be key to how important the project is going forward. So with that, I would turn it back to Representative Bolden.
Thank you so much, Ms. Elms. We do have one more presenter, Margaret Cherney Hendrick with Fresh Energy. Please introduce yourself and proceed.
Thank you, Mr. Chair, and good morning to the committee. My name is Margaret Cherney Hendrick, and I am here on behalf of Fresh Energy. Fresh Energy is a Minnesota-based clean energy nonprofit working to achieve equitable carbon neutral economies by 2050. And in this spirit, we appreciate the opportunity to be here today in support of House File 4436. So we want to start by thanking Representative Bolden and the City of Rochester for bringing this important proposal forward. While Minnesota has made progress reducing emissions for our power sector and transportation sectors, emissions from commercial and residential buildings have risen the most quickly of any other sector of Minnesota's economy. Since 2005, emissions have risen 15% from commercial buildings and 32% from residential buildings. At Fresh Energy, we really believe that district energy systems represent a cost-effective, scalable solution to help meet our climate challenge, improve public health, and provide equitable and reliable heating and cooling to Minnesota's buildings. A ground source district energy system, by definition, is a heating or cooling system that uses the constant temperature of the earth or underground aquifers to heat or cool multiple buildings connected through a piping network. By comparison, ground source district energy systems are up to 8 times more energy efficient than natural gas systems. Because ground source district energy systems distribute heat and not carbon-based fuels, they are carbon and pollutant free. Of particular note, these systems work especially well in cold climates because they rely on the constant temperature of the earth, therefore providing heating and cooling reliably through extreme heat in summers and extreme cold in winters. Their vastly superior energy efficiency also confers lower energy bills and puts less pressure on the electric grid as we see electrification across other sectors of the economy continue to advance. Fresh Energy believes investing in district energy systems like the municipal district heating and cooling system proposed in Rochester is extremely important. These types of systems are already being deployed at utility scale by National Grid, Eversource Energy, and NYSERDA on the East Coast. We know we must decarbonize our building sector to meet Minnesota's greenhouse gas reduction goals, align with the governor's climate action plan, and stave off the worst impacts of climate change. Deployment of district energy systems in Minnesota will also help to chart the path for a just labor transition. Workers currently managing buried infrastructure that moves carbon-based fuels like natural gas have a clear path to management of very similar systems that instead move around heat. Ground source district energy systems are safer and healthier for pipeline workers and building residents, reducing explosive accidents and exposure to pollutants. The lower energy bills, cleaner air, and reliable service conferred by district energy systems also contribute to a just energy transition in Minnesota's building sector, especially so in under-resourced and overburdened communities. We must invest in innovative energy infrastructure projects like the one proposed in the city of Rochester to demonstrate the climate, energy, workforce, and public health benefits of district energy systems. Initial investment now will de-risk future investments and allow systems like this to be deployed at scale across the state. We appreciate the committee making time to consider this significant and innovative new project and encourage members to find a path forward for this legislation before concluding the 2022 legislative session. Thank you.
Thank you, Ms. Cherney Hendrick. Next, we'll turn to member questions, and I have a couple to start us out. First, thank you for bringing this proposal, Representative Bolden. I think it's a really exciting one, and Ms. Elms mentioned how unique this would be in the state of Minnesota. I know that we have the example that was cited of Carleton College that has done this at the district energy scale for a campus, but I think moving this to the scale of a city is a pretty exciting opportunity. The question I have for either Ms. Elms or Councilmember Keen is, I know in the one pager, there was a mention that the general obligation bond is not a route because of potential future connections. And I was wondering if one of you might be able to expand on that. Councilmember Keen, looks like you've come off mute.
Well, I'll just start out that we have worked through, and I'll let City Administrator Zelm speak too, but we have run this thing that the bonding is, we have problems with bonding when we are going to have future private connections to it. So we've been trying to work through those in the Senate, working on the cash options and not going general obligation. But there are many other like different avenues we've been trying to work through that. And I know Representative Bolden's been actively involved with those. City Administrator Zelms, do you have anything to add?
Ms. Zelms.
Chair Long, Councilmember Keen, committee members, yeah, it's really ideal and essential that it becomes a cash option because of the unique nature and those future connections and its ability to become even more efficient over time. And really any future building footprint that's connected to this is going to be using its space for its most valuable purpose, and connecting into district energy really allows for that. So the Minnesota Management and Budget Agency has been working closely with us, and they made it pretty clear that caches are really our only option for the system that we've proposed.
Got it. Thank you. And those projects were some of the affordable housing developments and others that you mentioned earlier.
Correct.
Great. Representative Swazinski.
Thank you, Mr. Chair. And just how much money is the city of Rochester putting towards this project?
Ms. Zelms.
Chair Long, Representative, the request is a matched request, and the city would be putting $15.8 million towards the project.
Representative Swazinski.
Thank you, Mr. Chair. And just what funds is the city using? Like, are you using reserve funds? Are you using rainy day funds? What funds are you using within the city?
Ms. Zelms.
Thank you. We would be looking at a combination, and we have earmarked part of our rescue plan dollars for this. Obviously, we need to rescue ourselves with some heating and cooling, and so doing that in the most effective way possible is what we're looking for.
Representative Swazinski.
Are you going to be raising local property taxes at all?
Councilmember Keen.
We planned on doing this without raising, but it has become, it's normal part of running the city that is under property tax. And we're trying to keep that as low as possible by really focusing now on the ongoing costs for energy as opposed to the upfront costs. We really like to do this with state assistance to keep, and with our 50-50 funds through things like rescue plans. And we are also dealing with some DMC money in this because of the long-term private investment going into it. And that's also a part of the scaffolding of funds on the city side.
Representative Swazinski.
Thank you, Mr. Chair. So you'll be using what percentage of DMC tax money are you using?
Councilmember Keen.
I'm going to say quickly in the range of 15% of the city's obligation. I don't know if somebody can correct me. I think it's in that range.
Ms. Zelms.
Chair Long, Councilmember Keen, Representative, committee members, I think it's also important to point out we have got to replace our heating and cooling system one way or the other. So we will be doing the equivalent of that city share, either with traditional systems or with this more cost-effective system that will save on the long term.
Representative Swazinski.
Thank you, Mr. Chair. And then, so this, because of the state grant, will you plan on repaying this as you save money going forward, or will you just pass that on to your taxpayers?
Representative Bolden, maybe that, since it's a question to the bill.
Thank you, Mr. Chair. I'm not sure I'm fully understanding the question. Could it be repeated?
Representative Swazinski.
Certainly, Chair Long. Representative Bold, just from a, it was stated that the reason the grant request is to save money for people of Rochester using state dollars, and it sounds like federal stimulus money or rescue money is there any plan to pay those savings back to the state, or will you just keep those for your taxpayers?
Representative Bolden.
Thank you, Mr. Chair. And I guess I would say just this is a normal, the normal course of providing heating and cooling to public buildings. As Administrator Zelms said, this is a system that it's at the end of its life and so needs to be replaced either way. And so looking for that 50-50 investment from the state to do so.
And I think the benefit to the state would certainly be the innovative nature of the project and the ability for other cities and areas to learn from it. Representative Swazinski, do you have further questions?
Thank you, Mr. Chair. And then just kind of wondering from the city's perspective, we're hearing this at the last minute. Was this just all of a sudden, oh my goodness, we have to replace this? Or was this kind of like, hey, we have an opportunity to go to the state, let's do this? Or kind of what was the process and timing and the rest to come kind of at this late hour on this project? Was it just, did you realize this was failing, or was
I can maybe speak to the hearing timing, Representative Swazinski. We think the bill had been referred to our committee, and it had been my understanding that bonding was a potential avenue. But I learned last week that because of the ability to potentially expand into some of these future affordable housing developments and others, that general obligation bonds were not a possibility. So that's why I wanted to hear the bill. Representative Swedzinski, did that answer your question?
Yes, and Mr. Chair, just was wondering, does this still fit if this is going to be placed in your omnibus, I'm guessing? Does this still fit within your parameters of your budget resolution? And then what is that number?
So the request number, I believe from the one pager is 15.8 million, and have not made a decision yet, Representative Swedzinski, about what the possible path forward is for the proposal. Representative Swedzinski.
Mr. Chair, just what is your total spend allotment, and will it displace other projects?
So we'll be in Ways and Means later this week, and the amount that we have in our spreadsheet for general funds out of the Energy Committee, I believe, is 80 million. So yes, it would. I mean, if we were putting this in the bill, then it would be displacing others. Representative Swedzinski.
Thank you, Mr. Chair.
Further questions, Representative Bierman.
Thank you, Mr. Chair. Thank you to Representative Bolden for bringing the bill forward. I'm a fan of what Rochester's doing down in the city with innovative projects. And I did have a question though, in hearing that the useful life of the steam plant is 2023, and doing a project of this magnitude, how long will it take to implement this, and what sort of plans are in place to bridge the gap between the new and the old? That's a question for, I guess, maybe Councilmember Keene, please.
Councilmember
Yes,
Keene.
thank you. Thank you for the question. We are building this as a scaffold platform. We're doing a lot of the work up front so that over time we can add new capabilities to the district. Up front, we're doing a combination of of geothermal that we do think we can get up pretty quickly for some of the buildings, but we're not planning on building everything out in 2023. Our focus is we have 5 city buildings that we need to be prepared to heat and cool come the fall of 2023. But over time, as these other properties get developed, we'll scaffold up the district energy. That's the way we're building it, so that we can add not only things that we know about today, but future capabilities as they become more tried and true, that we'll be able to add these new energy sources into district energy to keep us on the cutting edge going forward.
Representative Bierman.
Thank you, Mr. Chair. That was really my only question, just the timing of that and a little more expansive view on what's happening. And I appreciate the information, and hopefully this will go forward in Rochester and be a good thing, as has been mentioned, for the state of Minnesota. Thanks.
I'm not seeing further hands. So Representative Bolden, would you like to make closing remarks to the bill?
Yes, thank you, Mr. Chair. And just thank you again to the committee for hearing this project. Just a couple of notes, one about timing, just to make mention that this has been on the list of Rochester's legislative priorities since last fall, and was featured on bonding tours this last year as well. Also, I just want to be sure to also thank Chair Liebling, who was actually the chief author of this bill and is currently presenting the HHS bill in Ways and Means. So as a co-author of the bill, I'm very happy to be here to present to you all today. So also just want to thank the committee for your work and focus on energy and the environment. And so again, thank you so much for hearing the bill.
Thank you, Representative Bolden, and thank you so much for being willing to step up as a co-author with Representative Liebling unavailable. Thank you to our presenters on this bill for this really exciting and innovative proposal, and appreciate you all being here with us this morning.
Thank you.
All right. Members, next we are going to be hearing 2 presentations, and I think we will take both presentations and then have time for questions. And so our first presentation will be on the climate projections for Minnesota, and that will be from Dr. Tracy Twine with the University of Minnesota. Dr. Twine, welcome to the committee. Please introduce yourself and proceed.
Thank you, Chair Long, and good morning to you and to members of the committee. Thank you for inviting me here today. I'm happy and excited to tell you about our recent project. My name is Dr. Tracy Twine. I'm a Minnesota. right, I'm going to share my screen. Are you see this?
We are, your audio is cutting in and out a little bit, Dr. Twine.
As, as soon as I shared my screen. Okay, thank you, Chair Long. I will
It may work better if they don't share.
stop my video if you don't mind.
Well, I think the slides may be
If I don't share the screen.
important to the presentation. Yeah, let's see if we can. Let's see how we go with the presentation, then I'll let you know if we're having additional trouble hearing you.
Okay, thank you, Mr. Chair. Yes, please interrupt me, and I can move to another location if I need to. So good morning. I'm going to give you some results of a recent project where we have looked at projections to Minnesota's climate throughout the 21st century. We already know, based on our evidence, that Minnesota is getting warmer and wetter. As we can see, these just two examples of some recent floods from both the northwest side of the state near Fargo and the southeastern side of the state more recently. And there are floods in Duluth in the northeast, also some floods in the southwest. Central parts of the state, flooding is getting more frequent, temperatures are increasing, and so we want to take what we know and ask what's going to happen in the future. So far, warming has really been a winter phenomenon. This slide here is showing us from as far back on the record. On the left, we have annual average increases. So this is total temperature change in 3 sections of the state, kind of broken up arbitrarily to the north, the central, and the south. And you can see that they're pretty.
Dr. Twine, your audio is going out a little bit.
One direction. If we just look at average, let me move. All right, I apologize, Chair Long.
No problem.
If we break up this annual average temperature into the average low temperatures in winter and the average high temperatures that we have in summer, you can see that these trends are quite large in winter, where our low average temperatures in the north have increased by 7 degrees Fahrenheit over the period of this record, and have increased about 4.7 in the south. So in the summer highs, you can see we have some small warming in the north and central region, a little bit of a cooling in the south. So far, this has really been warming for us during winter. This is the observations that we have here. This record are consistent with what climate models, global climate models, are projecting as far as these trends to continue. So this is a slide from the recent 6th report of the IPCC. And so if we have a 2-degree global warming increase, this is showing North America temperature in winter and summer on the left, increases in precipitation in winter, summer on the right. And you can kind of, if you can picture where Minnesota is, you know, there's kind of a 1 value increase at that location, and maybe, you know, a 1 value increase in precipitation. So what we want to do is take these projections and get finer resolution. Our state is quite heterogeneous. We have a lot of biomes with forest to the north, agriculture in the central and the south, some grasslands, some urban areas. So we want some more information that can help our state make plans that are appropriate for various regions. So our question was, we know it's warming, it's getting wetter, but when are these rainfall events happening? When is it going to continue to get warmer? Where is this going to be? How often are these extreme events going to happen? So what our project has done is taken the global scale projections, which are accurate, as accurate as we can be, But we want some more information, some finer information. And so this is what our model will simulate if we look in our historic record from 1980 to 1999. So you can see, this is winter average, colder to the north, warmer to the south, but you can see that the heterogeneous landscape, and you can even pick out some lakes here in the state of looking what the model projects for the past. You might also notice from that global map that I showed you that we really didn't see any of our lakes. The global models have the Great Lakes represented, but they're too coarse of a scale to really represent, the more than 10,000 lakes that we have in the state. And they are very important, and they affect at least the climate close by the shoreline. And so we need to account for this too, and this is what my group is working on. What we did was use 8 of our global climate models and used a physical weather model to get some finer information at a 10 kilometer by 10 kilometer resolution across the state. And we made sure that when we ran it in the past, that any differences that we had with observations were corrected, and then we would project those corrections into the future. So what we find, if we just project to mid-century, about 2040 to 2060, with if we have some mitigation of greenhouse gas forcing, this is what we project for the winter. In the south, it's about a 2 degrees Fahrenheit increase, and in the north, about 3.5. You can see the variation with the scale here, but I've just decided to point out some of the main average areas, average values there in parts of the state. If we go to the end of the century, the bottom figure shows you if we just have business as usual and don't mitigate any of our greenhouse gases, we're projected, maybe up to 12 degrees Fahrenheit warming up in that northwest quadrant. You can see kind of 10 degrees Fahrenheit in the middle. If we do tend to mitigate such that the globe follows a lesser forcing pathway, what we show up in the top right is an increased warming average winter temperature of 6 degrees Fahrenheit. Summer, where we didn't see much of a warming trend so far in Minnesota, it changes now. So this is a little bit concerning, such that if we go unmitigated, our average summer temperature is projected to increase by 7 degrees Fahrenheit. If we mitigate up in the upper right, we could reduce that increase to only a 4 degree Fahrenheit increase. Now, looking at precipitation, as we know, precipitation is quite variable across our state, and even across any region or metro area. It could rain in some location and not rain in another. It's a complex process to model. And so what you'll see with these gray lines is a lot of variability. And this is a statewide average, and this is all of our model runs. So the dark line you'll see there from January to December on the left is showing us when we average all of these results, what we get in terms of simulating the end of 20th century. On the right, what I'm pointing at there is this black line, which is the forecast, the projected value there. And then the dashed black line is the history. And so you can see that the model projects with pretty good certainty that will be wetter in every month except July, where it's pretty close there. So we have confidence that Minnesota will continue seeing wetter springs. No evidence to suggest that summer precipitation so far is going to vary that much. When we look across the state to see how it varies, what on the left is the historical run of precipitation, a drier northwest, a wetter southeast to the state. And with unmitigated emissions down at the lower right, the northern half really of the state is showing some increases in spring precipitation and up to about 1 inch per month of spring precipitation up in the north there. We also looked at snow depth changes. So back to winter, we've got a historical simulation of snow depth on the left. unmitigated, we might have an average winter snow depth decrease of about 5 inches at the most there in the kind of the east central location of the state. Not much change to the north, which is great. And then if with the mitigated runs, a decrease in average snow depth of 3 inches. And then finally, looking at the number of days with snow cover. So we have our historical average there on the left. And on the right, this is where sort of in the middle of the state in the lower right, you might see, if I've got my laser pointer here. So right here, you know, in the middle of the state is where we see the greatest decrease of days with snow cover. And that can be up to, you know, maybe 50 or so. So 50 fewer days in the winter season on average. So what our study showed is that, you know, we are consistent with what the global climate models project. We are just trying to get more detailed information across the state. We project that there would be continued warming in winter. We would see an increase in summer warming from what we've seen. Fewer days with snow on the ground. These changes should be mitigated. If there are reductions in greenhouse gas emissions, we will also need to adapt to these events that we're going to have. So what we have in the works is updating the data that I just showed you with the new projections from global climate models. We'll refine our output by accounting for all of the many lakes in the state and how they can influence the region around them. And we're working on how to help people use this data. I'm a nerdy scientist, and so I speak my own language of science and this data. It's nice if the projections that we have here could be useful to your constituents. So that's what we're working on now. These are the authors of the study, thanks to funding from the LCCMR. And I thank you for your time, Mr. Chair.
Thank you so much, Dr. Twine. So we will hear our next presentation, and then we'll come back to questions for you after that. Thank you. And next, we are honored to have with us Dr. Stephanie Rowe, who was a lead author of the IPCC third working group report that just came out recently, and is global climate and energy lead scientist at the World Wildlife Fund. Welcome to the committee, Dr. Rowe.
Thanks for having me. Can everyone see my presentation?
Yes, we can.
Okay, excellent. Well, my name is Stephanie Rowe, and I, as the chair just said, I'm a lead author of the Intergovernmental Panel on Climate Change 6 Assessment Report, focusing on Chapter 7, which is on the agriculture, forestry, and land use. I'm also the global climate lead scientist for the World Wildlife Fund, and I'm honored to be presenting to you today the findings of the latest IPCC report on the mitigation of climate change. So Working Group 3 report on the mitigation of climate change is the third part of the 6th assessment. The first part, which was released on August 6, 2021, focused primarily on the causes of climate change. The second, which covered the consequences of climate change, was presented to you by Dr. Lempert last month. And so this third assessment mainly describes the solutions to climate change. And there will be a synthesis report that combines these reports together in October of this year. Our assessment was prepared by 278 authors from 65 countries, and we reviewed more than 18,000 scientific papers and considered close to 60,000 individual comments from governments and experts as part of the drafting process. So all of this feedback has really helped to strengthen this report. So diving right into the findings, our assessment shows that greenhouse gas emissions, which are the cause of global warming, are at their highest levels in human history. So emissions in 2019 were about 12% higher than they were in 2010 and 54% higher than in 1990. So we are not on track to limit warming to 1.5 degrees. The emission trends vary by region. So over the last decade, 80% of the net growth occurred in Asia and the developing Pacific, which you can see in the figure to the left in the dark red, in the dark red color. But developed countries, including the United States, continue to have the highest cumulative and per capita emissions, which you can see in the middle and the right figures. Emissions by sector are growing across all sectors, and you can see that the emission share by sector is shown in the top figure, which looks at direct emissions, and then the bottom figure looks at direct and indirect emissions when you consider where energy is used. Growth in energy and industry slowed in the last decade, but there's a steady increase in the transport sector of about 2% per year. So the energy sector makes up about a third of emissions. Industry is about a quarter, agriculture, forestry, and other land use 22%, transport 15%, and then buildings at about 6%. Our assessment concludes that unless there's immediate and deep emission reductions across all sectors and across all regions, limiting warming to 1.5 degrees is beyond reach. But there is also good news. The good news is that there is increased evidence of climate action. Around 20 countries, including the US, have achieved a steady decrease in emissions for over a decade. And some countries are achieving rates consistent with limiting warming to 2 degrees. There's also a growing number of cities that are setting net zero targets, and an increasing range of policies and laws have enhanced energy efficiency, reduced rates of deforestation, and accelerated the deployment of renewable energy. So one notable success is around renewables. So since 2010, there have been sustained decreases in costs with reductions of about 85% for solar energy, 55% for wind power, and 85% for batteries. And in some cases, these costs have fallen below those of fossil fuels. At the same time, we've seen large increases in the capacity installed, as this figure shows here. And electricity systems in some countries and regions are already predominantly powered by renewables. With current policies up to December 2020, we conclude that GHG emissions or greenhouse gas emissions are projected to lead to global warming of about 3.2 Celsius. In the scenarios we assess, limiting warming to 1.5 will require global greenhouse gas emissions to peak before 2025 at the latest and be reduced by about 43% by 2030. And emissions from methane, which is a short-lived but potent greenhouse gas, would also be reduced by about a third over the same period. Even if we do this, it's almost inevitable that we will temporarily exceed 1.5, but we would return to below this level of warming by the end of the century. Limiting warming to 2 degrees still requires global emissions to peak before 2025 and be reduced by about a quarter by 2030. So how can we reduce these emissions? Well, in every sector, there are options available now that can have emissions by 2030 and keep open the possibility of limiting warming to 1.5 degrees. And many of these options result in net cost savings and deliver social and environmental benefits, including more jobs. This figure shows here a list of some of these measures across the different industries, and you'll see that the different bars represent cost categories, whereas the blue bar represents the net cost savings. So costs are lower than the reference technology. So I'm going to highlight some of these solutions in the next slides. The energy sector accounts for about a third of all emissions, and major transitions are required to limit global warming. So this will involve a substantial reduction in fossil fuel use, low or no carbon energy systems, widespread electrification, the elimination of fugitive emissions, which account for about 20% of energy or 18% of energy emissions and 36% of methane emissions. The use of alternative fuels such as hydrogen and sustainable biofuels, use of carbon capture and storage, and improved energy efficiency. Transitioning to a low carbon energy sector is expected to cut down international trade in fossil fuels. Looking at the transport sector, reducing demand plays a key role in reducing emissions, as well as low carbon technologies. Electric vehicles offer the greatest potential as long as they're combined with low or zero carbon electricity sources. And advances in battery technologies could assist in the electrification of trucks and complement conventional electric rail systems. In aviation and shipping, which are harder to decarbonize, alternative fuels such as low emission hydrogen and biofuels would be needed. Overall, there's a substantial potential for emission reductions in the transport sector, but this depends on decarbonizing the power sector. In buildings, solutions involve retrofitting existing buildings and using effective mitigation techniques in those buildings that are yet to be built. And that includes implementation at the design, construction, and use phase. And of course, doing this will require ambitious policy packages, which may incorporate the use of renewables and efficient design and use of space, energy, materials, and appliances. Cities and other urban areas account for more than 2/3 of global emissions, so it presents an opportunity for resource efficiency and decarbonization at scale. In all cities, better urban planning is key. 3 other broad strategies have been found to be effective, which include sustainable production and consumption of goods and services, electrification, and improving carbon uptake and storage in cities, for example, with permeable surfaces, green roofs, trees, and lakes. Agriculture, forestry, and other land use accounts for almost 1/4 of global emissions and can provide large-scale emission reductions and remove and store carbon dioxide at scale. This can be done by protecting and restoring natural ecosystems, including forests, peatlands, coastal wetlands, savannas, and grasslands. And of course, improved and sustainable crop and livestock management also play an important part. Land provides us with a lot, for example, food, nature, livelihoods, and feed for animals, and these competing demands have to be carefully managed. But land, of course, can also do so much, and it can't compensate for the delayed emission reductions in other sectors. Changes to our lifestyles and behavior can reduce our carbon footprint as well as improve our health and well-being. So the report finds that there's untapped potential to bring down global emissions by about 40 to 70% by 2050, but only if the necessary policies, infrastructure, and technologies are in place. And this includes walking and cycling, electrified transport, reducing air travel, adapting houses to make them more efficient. And to be effective, lifestyle changes will need to be supported by systemic changes across all sectors, which this figure shows. You'll see on the left panel, there's potential to reduce in the food system, and then industry, land transport, buildings, and electricity. And these are able to be delivered through changes in sociocultural factors and infrastructure use, as well as in end-use technology. The wealthiest 10% contribute about 40% of emissions, and so have the highest potential for reductions, not just as consumers, but also as investors, influencers, and professionals. And to improve our chances of success in implementing climate change mitigation, our assessment shows that financial flows would need to increase by 3 to 6 times by 2030 to limit warming below 1.5 or 2 degrees. And the finance gaps are the widest for developing countries and the land sector. Of course, policies and economic instruments also play a crucial role, and our assessment shows that policies that result in wider benefits to society, have broad public support, can increase the pace depth, and breadth of emission reductions. So here's an example in urban areas. We see that green and blue infrastructure like green roofs and facades, parks and open spaces, wetlands, urban agriculture, not only absorb and store carbon, but they can also reduce pressure on urban sewer systems, reduce flood risk and heat island effects. They can also deliver health benefits from reduced air pollution. So accelerated and equitable climate action and mitigating and adapting to climate change impacts is critical for sustainable development. And to conclude, climate change is the result of more than a century of unsustainable energy and land use, lifestyles, and patterns of consumption and production. And this report shows how taking action can move us towards a fairer and more livable world. And so we know how to do it. we know what to do and how to do it, and the action, the time for action is now. Thanks very much.
Thank you so much, Dr. Rowe. I have a couple of questions to start us off, and the first question is to go back to Dr. Twine. So we're thinking about the IPCC reports and the difference between mitigated and unmitigated in the research that you presented for Minnesota. You had mitigated and unmitigated scenarios, and I was wondering if you could speak to what mitigated means. Is that consistent with IPCC? Was that what you were projecting?
Yes, thank you, Chair Long. Yes, exactly. So what climate modelers do, we'll just have to make scenarios because we're projecting into the future. And so we make some projections of if we had this amount of emissions, this is the type of climate that we might see if we were to reduce those emissions by a lot of the examples that Dr. Rowe just pointed out. You bring the global average concentration of greenhouse gases down, so there's less of that amplification of warming and increases in extreme rainfall and all of the impacts that we get from climate change. So we sort of bound these by, what we have today. If we didn't do any type of mitigation, this is the worst possible scenario, perhaps. It's just a scenario. And then we can kind of give what if examples in between, just to help. Basically, the biggest uncertainty is our decisions, what humans decide to do. The physics is there. It's quite complicated, but the biggest uncertainty and the biggest driver that we have is how humans use the land and their emissions, as Dr. Rowe pointed out.
And Dr. Twine, the differences were pretty stark between unmitigated and mitigated for Minnesota. Large differences in temperature change, large differences in snow cover. I'm wondering if there are one or two that stood out to you as the biggest changes we'd see in a mitigated world in Minnesota versus unmitigated.
Right. Thanks, Mr. Chair. I think it has to do with our location right here in the mid-latitudes, halfway between the equator and the North Pole. We're still a northern state, and so that's why we're one of the fastest warming states. So a lot of the mitigation, so we're sensitive in the sense that we're warming very rapidly, but we also have that opportunity to reduce that warming. And changes are already happening, so we're already adapting. But it's not, as Dr. Rowe pointed out, the time to act is now. We can make some changes. I think it didn't surprise me that the temperature is more homogeneous. It's pretty easy to simulate. So you reduce the greenhouse gas emissions, you reduce the warming. That's not a surprise. It's what is surprising is that we haven't had much of a trend in summer warming, but now we will. And so then that asks the question of how is that summer warming now going to impact more frequent droughts or even more frequent flooding if we have continued extreme rainfall as we're expected to. So that was a surprise. I'm not surprised that we'll see less snow cover because as temperatures warm, we get close to that melting point. And even if more precipitation falls still as snow, it's going to last on the surface a shorter time.
Thank you. And Dr. Rowe, there's, I think often when we think about the actions that we're taking in Minnesota, we know this is part of a global context, and you put out the context that we need to meet as a planet in terms of mitigation. I'm curious if you could just speak to what the mitigation efforts that we've taken as a planet have meant so far in terms of being able to avoid some of the worst outcomes that we see, and what it would mean to get to a 1.5 or 2 degree scenario versus some of the other scenarios that were projected.
Sure. Well, as I showed, there are about 20 countries that have been successful in being able to reduce their emissions for over 10 years. So sustained emission reductions cumulatively for over a decade, which is critical. However, none are on a path for reducing emissions to 1.5 degrees. Some have achieved emission reductions that are consistent with 2 degrees of warming, which is about 3 to 4 degrees, 3 to 4% annual emission reductions. And they've achieved this largely through efforts, both from a policy perspective, but also economic instruments that have been able to enhance energy efficiency, reduce the emissions from the energy sector, and also in a lot of tropical countries be able to reduce land use change, primarily from deforestation and the conversion of other natural ecosystems. We're seeing that transport emissions are, so energy is decreasing, not necessarily at the scale necessary to limit warming to 1.5 degrees, but we do see that there has been successes in making emission reductions in the power sector. However, in the transport sector, we do see that still increasing. And that is largely due to enhanced demand and increased demand. And so we think that, you know, there's a significant potential to be able to address transport emissions from the various solutions that I highlighted, including, you know, electric vehicles, both from passenger vehicles and light and heavy duty vehicles, including trucks. You know, improved batteries, for example, has a large potential to be able to improve the emissions from those trucks and also potentially from rail systems. But of course, additional innovation is going to be needed in the harder to abate sectors of transport, including aviation and shipping, which are not able to necessarily take advantage of battery technology at this time.
Thank you, Dr.
So yeah, thank you.
Vice Chair Acom.
Thank you, Mr. Chair, and thank you to both of our presenters. I actually have a question for each of them. And oftentimes when we consider climate change, the notion of the expense to implement strategies is often taken into account. So I was really struck by the avoided costs brought up in the IPCC report. And so I think that's a really important thing to take into account. And so Dr. Twine, last night at the State of the State, Governor Walz talked about that we had just deployed more National Guard members up to the northwestern Minnesota to deal with flooding. And so as we look at our wetter and warmer state and the how often we have to deploy or use resources to help with flooding, are you looking at any data and the costs associated with dealing with? So I know you're looking at making projections and you can look backwards and forwards in doing that. And is there any connection with the cost to our state, both in response and what we could be doing or potentially avoiding by investments?
Dr. Twine.
Yes, thank you, Mr. Chair and Representative Acom. I am not personally doing that. We are working with our collaborators who work in economics, work in public policy here at the university. But that is really important. What we can do is infrastructure, real estate. They have been using outdated metrics of looking at return rates of these heavy rainfall events. City planning, any number of sectors that need to plan for this. So we are trying to make these projections useful in the sense of that return rate so that people who work in the economics would be able to do a cost benefit analysis and see, you know, we'll always have flooding. We've always had that, but exactly, you're right. As it's more frequent, what is the expense for that?
Representative Acom.
Thank you, and I appreciate that. And Dr. Rowe, so one thing you just mentioned about in transportation is a more stubborn part or sector of transportation with aviation and shipping to electrify, and so using biofuels or other forms of fuel. So in Minnesota, we produce a lot of ethanol, and we produce it for a national market. And so I'm wondering help me understand if ethanol can play a role in our decarbonization of the transportation sector when looking at cars, light trucks, and so forth, or if electrification is really the way we need to be going at this point in time because of how quickly we need to be transitioning.
Dr. Rowe.
Thanks for that question. Yeah, so in terms of being able to get to where we need to be for 1.5 degrees, the passenger and light and heavy duty vehicles would need to transition to electric vehicles primarily, relying on low or zero carbon power sources. That is the most effective way to reduce emissions from the transport sector from that perspective. But obviously for aviation, that's not available. And so aviation is going to rely on sustainable biofuels. And at the moment, I'm not an expert on looking at the emission profile of different biofuels, including ethanol versus others. But of course, there have been differences in terms of studies that have come out recently in terms of the emissions profile related to ethanol versus others, including switchgrass or other feedstocks. And so, that can be considered, but really the consideration of biofuels relies on many other things, including the use of land, the use of water, the use of other resources that could potentially be used for other things. And so that also has to be weighed very considerably in making these decisions.
Representative Bacon, were those no further questions? Okay.
Yeah.
Representative Gruenhagen.
Oh, thank you, Mr. Chair. Yeah, thank you, Dr. Rowe and Dr. Twine for your presentation. I do have a couple of comments and then a question. I'm no fan of the UN IPCC, to tell you the truth. I've got information, they manipulate the data and to their own benefit. And in some cases it's fraudulent and outright not true. I won't call it a lie, but that's the next thing. I mean, all of these things are computer models and they can be manipulated. So I just would say that for us members on both sides of the aisle, I think you need to look at other organizations that have some concerns about the IPCC projections, such as the Heartland Institute does carry quite a bit of scientific data regarding that by scientists. And there are literally thousands of scientists who believe that increase in CO2 is actually good for the planet and the environment and not bad, and that we should be concentrating on methane more than CO2. But the last thing I wanted to say is that, as far as flooding, I have flooding in my district. I live in a rural district out here. And the interesting thing, people don't blame so much climate change or global warming or whatever you want to call it. They blame pattern tiling. In other words, we're draining more and more water into the rivers at a faster and faster rate. And we do need to address that. And that's the cause of more and more flooding versus climate change, at least in their opinion. And there's also some scientists that agree with that. So, the question I have is, number one, we know that alternative energy, windmills and solar does not provide baseload electricity. That's been documented here by testifiers in the past. But the interesting thing, I've received more and more information lately about Russia's involvement in our country, demonizing our fossil fuel industry and supporting alternative energy, which is hurting our country. Are you familiar with those articles? And when we cut off our fossil fuel industry, it raises the price of fossil fuels and oil from Russia, which they then turn around and use for committing the atrocities like against Ukraine, which they couldn't do before when oil was lower. So are you familiar with how Russia is propagandizing in our country in regard to demonizing the fossil fuel industry and supporting our alternative energy? Thank you.
I'll note, Representative Gruenhagen, that neither of our panelists are expert on Russian foreign affairs, but Dr. Rowe, if you'd like to respond, and then perhaps speak to the scientific rigor of the IPCC process.
Sure. Well, the IPCC is not necessarily an institution that makes data. What it does is it relies on hundreds of volunteer scientists, including myself. All of the scientists that were authors on this report do so as a public service and volunteer their time. And our job is to assess all available scientific evidence. So across the three working group reports, we reviewed over 60,000 scientific papers over the last decade that have been published over the last decade. And so our role really is to provide the most up-to-date, robust assessment of where the science is on climate change. And so it doesn't necessarily just rely on a set of models that are produced by one group. It looks at all of the studies that have been published to date in the scientific literature, which to be part of the scientific literature would need to be peer reviewed, goes through a rigorous peer review process. And so the findings of the report reflect the consensus of where the science is at this point in time. It does not make conclusions based on a limited set of available evidence. It looks across a wide body of all available lines of evidence. And so the conclusions are based on that. And in terms of the energy, certainly what we find in the report didn't look at specific instances of obviously conflict around the world, and obviously this report also was concluded before that occurred. But what the report does find is that limiting a warming to 1.5 degrees requires major transitions in the energy sector, and that reducing fossil fuels not only tackles climate change, but also can improve energy security. And that has been backed by multiple lines of evidence as well, because you are essentially relying on more energy used in the country. So I'll leave it at that. Thank you.
Mr. Chair, just
Representative Gruenhagen.
Yeah, thanks for that response, Dr. Rowe. My only response is, members, if you talk to an experienced weatherman, they have a hard time predicting weather past 10 days, okay? Here we're projecting decades of what the weather will be. So please take this with a grain of salt. Look for scientific articles and organizations that contest some of this IPCC UN stuff, which is primarily being promoted for tax subsidies, in my opinion. Thank you.
Dr. Twine, would you care to speak to the difference between climate and weather?
Sure. Thanks, Chair Long. It is true that we are not able to predict our weather beyond about 10 days at any location now. And the models that we use to project what the climate will be in the future are some of the same models. They use the same physics because the atmosphere has basic physics that we understand. However, climate is a statistic of weather, and so we can go back in the past and take all of the weather events and average them, and that gives us a normal climate. And so we're able to know with very good certainty what our average winter temperature was going to be this year, even before we had winter, because we're going to have cold days, we're going to have warm days. So these models have been run in the past, and they have done an excellent job of capturing the average of weather in what we know of as climate. It's an average weather. They do an excellent job of doing that in the past. And so in the future, all we can do is make these scenarios of what the human impact is going to be. But the physics is pretty clear and very well understood.
Thank you, Dr. Twine. Representative Lippert.
Thank you, Mr. Chair. And this question is for Dr. Rowe. And I just appreciate the presentation of both Dr. Rowe and Dr. Twine today. Thank you for being here. But Dr. Rowe, I'm wondering if you could comment on land-based climate solutions for a state like Minnesota. So we have forests, I believe we have more acres of peatland than any state but Alaska, roughly 21 million acres of cropland, mostly in corn and beans. Is there low-hanging fruit for a state like Minnesota in thinking about land-based climate solutions?
Dr. Rowe.
Thanks for that question. Certainly, land-based mitigation is something that could be very important for delivering both mitigation, adaptation, increased resilience, and also potentially some social benefits. So in the case of forests and peatlands, of course, we show that enhancing the role of forests in taking up carbon has significant potential, either through natural regeneration, through reforestation or forest restoration efforts, which I saw also the portfolio of the emissions in Minnesota as already delivering about 8 million tons of carbon sequestration in the state of Minnesota. So there's potential there also for potentially, enhancing that either through increased efforts in those types of activities, but also through forest management. So improved forest management can also provide potential by, for example, looking at different harvesting rates and cycles, and improving the health of the stands. Peatlands are one of the most carbon dense ecosystems on the planet. And they store an enormous amount of carbon over millennia. And when they are converted to croplands, they lose a lot of that carbon. And so that is a potential significant source for emissions when peatlands are drained or converted to croplands, drained, and then the decomposition of the soils then increases the emissions. So potentially, looking at ways to preserve peatlands, especially of natural ecosystems, could be some large untapped potential. As for croplands, the emissions from croplands arise primarily from cultivated soils, and that arises again from practices both either in disturbing the soils and which enhances decomposition and CO2 emissions, but also the application of fertilizer, both synthetic fertilizer, but also some natural fertilizer, but mostly from synthetic fertilizers where a lot of the emissions come from. And what we find is that improved kind of more precise application of fertilizer reduces a significant amount of nitrous oxide, which is about 300 times the potency of CO2. And it actually is able to have a lot of long-stream or downstream benefits, including reducing pollution in waterways, but also improving the amount of costs of input, that the farmers put in. So it can generate significant cost savings if more precision nutrient management is incorporated.
Representative Lippert.
Thank you.
Thank you, Dr. Rowe. That was very helpful. That's all for now, Mr. Chair.
Representative Bo.
Thank you, Mr. Chair. Thank you, Dr. Rowe and Dr. Twine. I'm assuming this question is for Dr. Rowe, but certainly whichever of you would like to jump in. I actually have two questions, if I may. The first is, how is the U.S. doing as compared to other countries in the world with regard to not only emissions, but then also cuts to those emissions?
Dr. Rowe.
So the IPCC, unfortunately, does not do country level assessments of emission profiles. It does regional assessments. And so we look at North America, for example, and North America, we do see that it significantly reduced its emissions over the last decade, but not in line with a 1.5 degree pathway. It also continues to be the highest cumulative emissions and also the highest per capita emissions. And so there is still significant potential to reduce it even further, to be able to be both in line with 1.5 degrees, as well as, to be able to reduce kind of the per capita emissions that we're seeing, at the highest levels.
Okay.
Representative Bo.
Thank you, Mr. Chair. Thank you, Dr. Rowe. Second question then, how are the largest economies in the world doing compared to others? Both for emissions and for cuts. I'm assuming larger economies translates normally into larger emission potential. So I'm wondering how they're doing emission-wise and also making cuts to those emissions.
Dr. Rowe.
Sure. Well, the regions is actually kind of categorized into developed and kind of undeveloped or developing countries, and they are by region. I believe I showed a figure with some wedges that looked at different regions across the world. With the last decade, 80% of the net growth being in Asia and the developed Pacific, or developing Pacific, sorry, and developing country or developed countries are still a large component of that. I'm looking at the figure now, and it is I believe it went from 29% down to 24%. So of global emissions. And so the developed countries have been able to make substantial emission reductions. And when I looked at the underlying literature to look at those 20 countries, you do see that the majority of those countries are in Europe, and the United States is included. So Western Europe, as well as a lot of Eastern European countries are included in that, and one in the Caribbean.
Representative Bill.
Okay, thank you. It's curious, you know, because obviously larger economies will tend to have larger emissions just because of industrial might, and also more developed lifestyles for the individuals. But then also you're wondering, or I wonder, how the more booming economies are making cuts, and if that's having an impact on economy, or if that's having an impact on willingness to make cuts that might impact economy and such.
I see. Yeah, so the emission reductions from the developed countries that I mentioned were able to do so in a sustained fashion over a decade, and were decoupled from economic growth. And so they did experience economic growth at the same time that they were able to reduce their emissions. And in terms of overall emissions, the developed countries are a smaller proportion in global emissions to Asia and the developing Pacific. But as I said, when you look at per capita emissions, it's still much higher. So we do still have kind of the highest per capita emissions around the world, but the total amount is now shifted to the Asia and developing Pacific.
Thank you very much. Thank you, Mr. Chair.
Thank you, Representative Bill. Representative Hollins.
Thank you so much, Mr. Chair, and thank you to both the doctors for their presentations. They were really informative. And I'm sorry if I missed this. I did get on a little bit late, but I wanted to hear from the doctors about the difference between how this temperature change is going to impact rural communities where there is less infrastructure and less population density to compared to metro areas. You know, I represent St. Paul, and I'm very appreciative of all the work that our municipality is doing to address climate change and to try to mitigate some of these effects. But of course, I have friends and relatives who live in greater Minnesota who are deeply concerned about this. And so I just want to know, you know, what mitigation strategies need to be taken currently, and why there is a need for statewide impact versus just municipal impact.
Maybe we'll start with Dr. Twine for that.
Okay, thank you, Mr. Chair, and thank you for that question, Representative Hollins. I didn't talk about urban areas versus rural today, but that's another part of my research. And so I have a recent master's student who was looking at historic records and then future records in 4 different urban areas around the state. And our big concern really is summertime when it's hot. That's the major difference between rural and urban. Our winters are pretty similar. Urban areas, if they're warmer from the urban heat island in winter, that's not so bad. In summer, we're concerned about the increase in our average temperature and increase in frequency of heat events that might happen. So the large heat waves that happen will affect urban rural areas together. When you're in an urban area that is not that doesn't have some cooling mitigation, then the ecosystems of plants and people just become more sensitive. And so that's where we're working with public health people to look at those critical thresholds of health for morbidity and mortality when these heat events come. And so when we looked at these same climate projections, we see that there's more frequent humid and warm air masses that come and into our region in the summer. And so if we have just one or two more of those each year in the future, then that's economic costs because of public health. So we're looking at that too. Thank you.
And Dr. Rowe?
Yeah, I was just gonna reiterate my point on urban areas, and that it globally speaking, accounts for almost 70% of global emissions. And so there's significant potential to be able to concentrate efforts related to resource efficiency and decarbonization at scale in urban areas. And also, and obviously better urban planning is a big part of that, but also looking at the demand side actions. So looking at how to be able to make it easier, more cost effective, and more convenient for not just consumers and citizens, but also professionals to be able to make decisions that can decarbonize. And that includes, city and urban planners, transportation planners, builders, investors. So there's various options that can be done and implemented to be able to address the mitigation component. As I mentioned and highlighted towards the end, there are a variety of different measures that can both mitigate climate change or reduce emissions, but also help increase resilience to climate change. So looking at blue and green infrastructure, for example, is able to, for example, looking at increasing green spaces, adding trees to cities, can reduce some of that heat island effect, and can buffer a lot of the increases in temperature, heat waves that are projected in the future. They are able to also potentially, buffer some other impacts related to, for example, any type of storm type impacts. And of course, reducing air pollution and making us healthier. So there are a lot of various options that can provide a larger suite of benefits to society and the environment if planned and implemented well. Thanks.
Representative Hollins, any follow-up?
No, thank you. That's really helpful.
Representative Liebling.
Oh, thank you, Mr. Chair. I just want to make sure if I heard that right. So urban versus rural, did you say 70% of the emissions comes from urban?
Dr. Rowe?
Yes, globally. So globally. Yeah.
Representative Liebling.
Thank you, Mr. Chair.
Thank you. I am not seeing further hands, and we're getting close on time. So I want to thank both Dr. Twine and Dr. Rowe very much for being here with us today and for your excellent presentations and insightful responses. Thank you.
Thank you, Mr. Chair and representatives.
Thanks very much.
Members, we don't have further agenda items for the day. I'll note that this is very likely to be our last hearing. We don't have other items that I'm intending to hear at this point. Of course, always reserve the right, but at this point, I suspect this will be our last time gathering with bills moving to Ways and Means into the floor later this week. So I just wanted to take the minute again to thank all our members of our committee for productive and great session together, and also in particular thank our hardworking nonpartisan and partisan staff for all of their efforts over the course of the last 2 years to make this such a great committee to work with and to be a part of. And with that, members, we are adjourned.